This is pre-algebra lesson 7-3, solving multi-step equations with fractions and decimals. Now, before we have solved one-step equations with fractions, and we've solved one-step equations with decimals, when you have multi-step equations with fractions and decimals, you can use similar strategies, but you may have to adapt and adopt a little bit to make it a little easier to figure out. When the coefficient of the variable in the equation is a fraction, we can use the reciprocal to solve the equation. For example, we have here a one-step equation. 4/5 x equals 12. X was multiplied by 4/5, which means we need to divide it by 4/5. But we should remember that dividing with fractions is the same as multiplying by its reciprocal. So I can take this equation and instead of dividing by 4/5, I can multiply by 5/4. If I do something to one side of the equation, I need to do the exact same thing to the other side of the equation. And remember, we can make all whole numbers a fraction by placing them over 1. On the left-hand side of the equation, we can clearly see that these cancel out, leaving me with x. On the right-hand side of the equation, you can cross-cancel. 4 divides into itself once, 4 divides into 12 3 times, and 3 times 5 is 15. 1 times 1 is 1, so we just have 15. We've done these types of problems in previous lessons. This is just a review, because what we're going to do is we're going to add a little bit to this. When you have a multi-step equation and the coefficient of the variable is a fraction, you want to make sure you gather all the variables on one side of the equation and all the constants on the other side of the equation prior to multiplying by the reciprocal. It doesn't matter which side of the equation you put all the variables on, and it doesn't matter which side of the equation you put all the numbers without variables on, but you must remember the rules for solving two-step equations still apply. Undo addition or subtraction, then undo multiplication or division. Let's take a look. Obviously, I want you to show all your steps so that we can learn what we're doing here. We have 3/4 p minus 7 equals 11. Now before, this is a two-step equation. I have p multiplied by 3/4 and subtracted by 7. So just like the rules for two-step equations, we need to undo addition and subtraction first. So I will undo the subtraction of 7 by adding 7 to both sides of my equation. I now have, the 7's cancel out on the left side, I have 3/4 p equals 18. To get p all by itself, I need to multiply by its reciprocal because it was multiplied by 3/4. We are going to divide by 3/4, which is the same thing as multiplying by the reciprocal of 4/3. If you do something to one side of the equation, you must make sure you do it to the other side of the equation. All of these 3/4 and 4/3 cancel out, leaving me with p. 3 divides into itself once, it divides into 18 6 times, and 6 times 4 is 24. And of course, I could check this equation just as easily as I've checked equations in the past by just plugging in what I know. I know that 3/4 times p, which is 24 over 1, minus 7 is supposed to equal 11. Let's see if this actually works. 4 divides into itself once, 4 divides into 24 6 times. 6 times 3 is 18. 18 minus 7, does that equal 11? Yes, it does, because 18 minus 7 is indeed 11. So it checks. Problem number 2 here. We have a negative 7/10 k equals plus 14 equals negative 21. So I need to undo addition or subtraction first. In this case, I will undo the addition of 14 by subtracting it from both sides. Pay really close attention to your negative signs in this problem. These 14's cancel out, leaving me with a negative 7/10 k. On the right side of the equation, I've got negative 21 minus 14. Which is the same thing as saying negative 21 plus a negative 14. Same sign, add your numbers together and keep the common sign, which is negative 35. Now we need to get rid of the negative 7/10 k that is multiplied, the 7/10 that is multiplied by the k. So we need to multiply by the reciprocal. And since we want a positive k, we must multiply by a negative 10 over 7. The negative sign just needs to be on one of the numbers. It's on both of the numbers and you're multiplying by a positive. So you only need one negative, because a negative times a negative is a positive. This will be 1, this would be negative 1, this would be 1, this would be negative 1, and negative 1 times negative 1k is just k. Whatever you do to one side of the equation, you need to do the exact same thing to the opposite side of the equation. So we had to multiply by negative 10/7 on the left-hand side, so we must multiply by negative 10/7 on the right-hand side. Again, we can cross cancel. 7 divides into itself once, divides into negative 35, negative 5 times. Negative 5 times negative 10 is positive 15. We have to be careful not to lose negative signs in these problems or you will get the wrong answer. Let's look at problem number 3. Here we have a fraction we must distribute. And for some reason, people can distribute it here, but they can't seem to distribute it here very well. They can distribute it to the m, but they have a hard time distributing it to the negative 6. So 2/3 times m is 2/3 m. 2/3 times negative 6 just means this. 2/3 times negative 6 over 1. B goes into 6 twice, and 2 times negative 2 is negative 4. And that equals 3. Or you can think of it as multiplying straight across the top, which is negative 12. Straight across the bottom, 3 times 1 is 3. Negative 12 divided by 3 is negative 4. So now we have 2/3 m minus 4 equals 3. Now we need to add 4 to both sides of the equation. So my 4's will cancel out here. And I'm left with 2/3 m equals 7. To solve for m, I must multiply by the reciprocal again. So I will multiply by 3 over 2. These 3's cancel out, these 2's cancel out, and m will equal 7 times 3 is 21, 2 times 1 is 2. You can leave it as 21 halves, or you can change it to a mixed number. If the decimal terminates, you can change it to a decimal, but only if the decimal terminates. If the decimal ends up repeating, it has to be changed to a mixed number or left as an improper fraction. So m's either 21 halves or 10 and 1/2. It's actually easier to leave it as 21 halves because if you had to check the problem, you'd have to change it back into an improper fraction before you could plug it in to check it. So I just tell everyone they can leave it as an improper fraction, unless it's a word problem, because word problems are going to leave in everyday language. You can use the multiplication property of equality to simplify the solving of an equation involving fractions. If you remember, the problem we just did only really had one fraction. Let's look back at them. We had the fraction here, we had the fraction here, and we had the fraction here. Only had one fraction throughout the entire problem. But when we go to these problems here, you'll notice there's more than one fraction. And when there's more than one fraction, sometimes it's a lot easier to clear the fractions completely from the equation before you add or subtract anything. We do this by finding the least common multiple of the denominators and multiplying everything by the least common multiple to clear your fractions. So let's look at this first problem. 2/5 x plus 2 equals 3/4. I don't want to have to deal with fractions because I don't want to have to find common denominators and do all that other fun stuff. I can do it, but there's an easier way. If I look at this problem, I want to find the common denominator between 5 and 4, which is 20. So I'm going to take this equation and I'm going to multiply every part of this equation by 20. So I'm going to multiply this by 20, I'm going to multiply my 2 by 20, and I'm going to multiply my 3/4 by 20. Now look what happens. 2/5 times 20. 5 goes into itself once and it goes into 24 times. 4 times 2x is 8x. 20 times 2 is just 40, because there were no fractions in this part, that part of the problem. 4 divides into itself once, and it divides into 20 5 times. 5 times 3 is 15, so that equals 15. Now look at that. No more fractions to have to deal with. No having to find common denominators, none of that stuff, because we already did that in one step by multiplying by the common denominator. So now I have an ordinary two-step equation. 8x plus 40 equals 15. Subtract 40 from both sides. 8x will equal 40 minus 15 is 25, negative 25, I should say. Divide by 8. And x equals negative 25/8. And of course, remember what I said, it's probably easier to leave it as an improper fraction than it is a mixed number. Because to check it, you have to put it back as an improper fraction. Or you can just make it as a mixed number, which would be negative 3 and 1/8. Either one is acceptable. I would prefer, since this problem was in fractional form, the answer needs to be given in fractional form. If a problem is given in decimal form, the answer should be in decimal form. If the problem is given in fractional form, the answer should be in fractional form. Let's look at problem number 5. Again, we have more than one fraction. So it's going to be easier if we take and deal with what the common denominator between these two numbers would be. Common denominator between 2 and 3. Common denominator is 6. So I'm going to multiply everything in the equation. Every part is going to be multiplied by 6. And I do this separately so you don't miss one part of the equation. Now I can start cross canceling. 2 goes in itself once, it goes into 6 3 times. 3 times 1y is 3y. 6 times 3 is 18. 3 divides into itself once, it goes into 6 twice, and 2 times 2 is 4. Again, no more fractions. Much, much easier than if you had to get your fractions and take 2/3 and subtract 3, get the common denominator, get that, and multiply by the reciprocal. You could do it that way. It's much longer, and you'll have a much higher likelihood of making a mistake. Now it's a two-step equation. I can subtract 18 from both sides. 3y equals negative 14. Divide by 3. Y equals negative 14 thirds, or negative 4 and 2/3. And there you have that equation. As you can see, it's not hard if you clear the fractions. For thing number 6, we need the common denominator between 12 and 6, which is 12. I'm going to multiply everything in this equation by 12. Don't forget the y here. So you can be in a world of hurt. Negative 7/12 times 12. Well, 12 goes in itself once, it goes to 12 once. 1 times negative 7 is negative 7. 12 times y is 12y. 6 divides into itself once, and it goes into 12 twice, and 2 times 1 is 2. So negative 7 plus 12y equals 2. To solve for y, I need to get rid of the negative 7. The opposite of negative 7 is positive 7, so we'll add 7 to both sides of the equation. And you're going to get 12y equals 9. Divide by 12, divide by 12. Y will equal, well, 12 ninths reduces. You always want to reduce your fractions to the lowest terms, even if they're improper fractions. You can leave it as an improper fraction, but reduce it. 9/12 divides by 3, so it'll be 3/4. So y equals 3/4. Now, you can solve multi-step equations containing decimals by calculating with the decimals or by multiplying by a power of 10 to clear the equation of decimals. Since you can use calculators, calculating with decimals is not too hard. But let's just say you lost your calculator. You had to do everything longhand because you had no calculator and nobody was going to loan you a calculator. And this was a test and you had to do well. It's easier if you work with whole numbers than if you work with decimals. So if we want to clear the decimals, we're going to use the decimal. We're going to multiply by the decimal with the greatest number of decimal places. Let's look at problem number 7. We have 1.5x, negative 3.6, and 2.4. Everything's to the nearest 10th. If we wanted to clear those decimals, if we multiplied everything by 10, we would clear the decimal and make everything a whole number. So I'm going to take this entire equation and I'm going to multiply it by 10. Which will move this decimal point and this decimal point and that decimal point one place over to the right. So I'm going to have 15x minus 36 equals 24. Now no more decimals because most of you do not divide by decimals very well. Add 36 because we need to get rid of anything that didn't added or subtracted. So these two things cancel out. 15x, 24, and 36 is 60. And if we divide by 15, 15 will divide into 60 4 times. And there we have our answer. Did not even have to touch a calculator. Made it very, very simple because we just need to multiply by 10. If we look at problem number 8, we'll see that we have 2 decimal places in this problem, none in the 3 and 2 here. So we need to take this entire thing and multiply it by 100, because we need to move the decimal 2 places to the right. So if we move the decimal 2 places to the right, 1.06p becomes 106p. Remember, 3 means the decimal is behind it, So 3 times 100 becomes negative 300, and that's going to equal 71, because we moved the decimal point 2 places to the right for every single problem, because that's multiplying by 100. So now I have 106p minus 300 equals 71. So I will add 300 to both sides of the equation. Those will cancel out. 106p equals 371. Now, even if I've lost my calculator, all I'm doing is dividing by a whole number, so it shouldn't take me anywhere near as long as if I was dividing by a decimal. So if I take 371 and I divide by 106, I should get 3.5. And like I said, since this is a problem that's in decimal form, we should leave the answer in decimal form. If it was a fraction, we'd leave it in fraction form as 3.5, but it is a decimal, so we should leave it in decimal form.